Everyone, myself Krish to very warm welcome to all. And this is day 15 of Foundation AI series. And in this day, we're talking about like basic maths. And previously, we discussed lots of about basic topics of the vector, like vector and vector addition, vector subtractions, dot cross and dot product, all these particular things. And I think like that's enough for the vector. And now I jump for the linear transformation. And today is like little bit I given an introduction about linear transformation and lots of topic about it. So overall agenda for today is all about something you can say. The first part is like linear transformation, and second thing is all about the eigenvalue and eigenvector. And this is a very important like this is a very beautiful topic, and I'm too much interested in like knowing to this particular thing. And like this particular topic is very necessary to discuss. Because of that, when you want to just making a model, you should to know about how this each feature like finding a pattern, like how this particular model are going to find out patterns between the like different data points and all this particular thing. So previously, like after this particular video, I will try to make a video on cosine similarity. This is a also important topic, and this is also a part of the linear transformation, but I will cover this particular in next video. But okay, at the end, as you know, like we already discussed the real world application, and I try to connect all the concept that you should to know about this particular. As we know, like this particular eigenvalue and active eigenvector is such as a abstract topic, but I will try to connect this all particular topic in such way like you can understand much clearly to this easiest way. And one more like basic thing that I want to say you, like something I'm not going to just looking toward the derivation formula and anything else and the depth of mathematics. So as we know, like anything, if you want to, if I explain you like how to find this eigenvalue and eigenvector, like this kinds of the formula, that's not very necessary to discuss. Because of that, I'm not going to discussing that that's kind of thing that we are not going to do. So we are understand only for theory how this particular concept work and what the idea behind this particular logic. So it's all about we are discussing lots of about this particular idea, what the eigenvalue and eigenvector. So we are discussing about it. So in fact, that's the interesting part, and I'm pretty sure that you understand this particular topic in very like after this real world example I've tried to explain you all in such way like how can you just connect this all this particular topic. So again, if this particular video is going to productive for you and if you learn something from there, then it's my pleasure. So let's get started. Okay, let's come to agenda number 1, and in this agenda we discuss about linear transformation. So what is the linear transformation, and why this particular thing is important. I will try to connect one real world application to understand this particular thing. So let's understand this particular thing, like what is the linear transformation. So the answer is your answer is like a linear transformation is all about something scaling a vector without any twisting or without any changing a direction. So that's the linear transformation. So it's all about vector scaling, like some vector, if you want to adjust some vector like magnitude and something what you want to adjust a vector, okay, but the condition is only for like without scaling, without like without twisting, without rotation. So you can scale a vector, but the limitation is like without twisting and without rotation. So this condition apply. Because of that, like this is important to discuss, because why this particular in AI, when you want to train a particular model, some features need to be stable for long term. If you want to understand this particular feature is a stay long term, how the what is the long term of particular feature in the particular understanding, so you apply this linear transformation to understand how the basic thing is happen. So we not need to just do it from the manual, but actually we know that all the Kubernetes frameworks and all this are designed for like initially did already all this formula is applied, but we need to understand like how actually architecture like how actually architecture work, how the actually model understand the two different contexts. So that's we need necessary for understanding linear transformation. So let's come to understand linear transformation is all about something like scaling a vector. Okay, so it's all about like scaling a vector by the limitation is all about like without twist and without like rotation and without any variation. Okay, so now suppose this particular vector uh, this particular vector, okay, now suppose this is a vector which actually indicate the parameter of the, let's suppose we take an example for understanding the population growth. So model want to learn a particular feature like how the actually population growth in their educated people. We give the data and educated and non-educated people. Now suppose this particular, so that this one is educated people, and this is uneducated people. Okay, so first one is educated and second one is uneducated. Both have one or such as one of the vector. Okay, so the model want to try to learn from this both features. So which one is like the population growth is where, okay, where is highest. The so according to it, like they use linear transformation method. Because of that linear transformation, when they want to learn, they need to adjust weight, biases and anything else. So that's the variable. So we need to adjust this particular vector during the training. Okay, like somehow this particular vector increase at some time. Okay, particular condition on particular any situation, and somehow the particular uneducated parameters will like this particular vector will increase. So the way to adjust, okay, so we need to capture this particular thing, like plotting this educated and uneducated. We not change this particular feature. So because of that, the condition is here to adjusting the both parameters, like scaling vector. We're not changing the particular direction. Now suppose this particular vector, we are not tilt this particular vector by rotation method or twisting a method to just change the vector. Okay, not to convert. This is not a like you cannot convert this particular vector by twisting methods, like now twist this particular vector to x-axis or something all different way. Okay, so here the condition apply, you can adjust the particular vector magnitude without twisting or rotation. Okay, so this feature is about now suppose there's two parameter, like for finding a population growth, like a model try to understand like learn the which particular groups have more population. Is it educated or it is uneducated? The way to understand is all about something they can try to learn from educated people and non-educated people, like uneducated people. Okay, the only simplest way, they're using a linear transform. So during the training they need to adjust sometime like different parameters, like scaling a vector, like sometime the magnitude will increase and sometime the magnitude will decrease. Okay, so the direction and the value of the increasing and decreasing during this training, that's called the eigenvalue and eigenvector. So eigenvalue refer to the magnitude that change according to their eigen particular thing, and eigenvector is just something work like different. Okay, so that's an important part to discuss. So linear transformation refer to that if you give an input, the vector changes. Okay, so here that weight and bias is applied and the vector will be try to change. Okay, without twisting or rotation. So the vector will remain same at direction, and but the value will be changed, and vector length like short and something okay, short and sometime elongate, sometime stretch, sometime near to zero, sometime above the zero. So that's important. Okay, so that's the way to understand the linear transformation. On my definition, linear transformation is all of scaling factor. Okay, scaling factor that actually have a limitation, like you are going to like scale this vector, but limitation applied here is all about something but like you are not going to twist this particular vector, but okay, that's the condition applied, and not going to rotate this particular vector. So that's the important part. And I think like two rule of this linear transformation have a two rule. The first rule is like same transformation. Okay, it's all about something like our first condition is like you're going to transform this particular value, okay, this vector. You are going to just stretch this particular vector. Now suppose this vector length is 5. Now you're going to just change this particular vector to 6. Magnitude will increase, but the limitation is the same transformation happen both sides. You can also reverse this vector, but you are not going to just you are not going to just rotate this vector for giving a different dimension, different features. If you rotate the vector, then I think like features will be rotated, and all this particular thing change. So the first condition apply. First rule is like same transformation. Second rule is about scaling. Okay, so the first priority for particular linear transformation, first scale the value, then after transformation happen. Now suppose this particular thing in this formula, let we know apply this particular formula, linear transformation have some formula. So we need to just adjust the value first. Okay, then after you are going to show the transformation, the first scaling and second transformation. So that's the important part to discuss about linear transformation. And if I give a best example like educated and uneducated parameters, so the both parameter actually adjust itself but in same direction. They are not going to change educated to different features and something, all this particular thing. So that's the important to discuss. Okay, So linear transformation is about vector scale, like scaling a vector with a different like the limitation is here is all about not changing to by twisting and rotation and all this particular thing. So that's all about the linear transformation. And okay, let's come to the next topic. Let's come to agenda number 2, and in this agenda we're talking about eigenvalue and eigenvector. So what is eigenvalue and what is eigenvector? Basically, if you're going to definition of this both of them, again I will say you like what we are going to discuss. We are going to discuss about the idea behind this eigenvalue and eigenvector, why this particular topic is necessary. I'm not looking for the formula and how can you manually find this all this particular thing like eigenvector and eigenvalue by the formula applying. This is not necessary to discuss. Because of that, as we know, like this all particular thing happen inside the computer and the computer do itself. We are not going to do it, but we need to understand what the idea behind it and why this particular approach is used in such as looking toward this all particular thing. So let's come to discuss. First of all, like eigenvalue and eigenvector. So eigenvalue refer to something you can say like it's all about something you can say it is all about something the vector which is not changed direction. So unchanged vector, unchanged direction. Okay. So if I give a two word that actually describe the both like eigenvalue and eigenvector, that I think like scalar quantity. Eigenvalue refer to scalar quantity. Right? It is a scalar value. Okay. Okay. And eigenvector refer to unchanged direction. So the vector we have they never change its direction. So that's the called eigenvalue and eigenvector. So that's a necessary part to discuss. Okay. I think like let me try to explain you this particular eigenvalue and eigenvector in such way like you understand much clearly. Again, we take a lot example like population growth. Okay, so let me take a two parameter which basically grow population. This is a feature 1 and this is a feature 2. The first feature refer to their educated group. And second feature refer to their uneducated group. So educated group and second feature refer to the uneducated group. So the growth of population in the both parameter, like first one is educated, second one is uneducated, after both how they both are grow. Okay, so that's the nice way to discuss. Okay, so the first one like F1, the feature 1, feature 2. Okay, as we know, if we tilt the direction, if we tilt the direction of the vector, then I think like the vector direction will change, the feature will change, the property will change, and the model will not find a pattern in some specific direction. Okay, so this is a two parameter and we need to look this like on this growth of educated, like how much educated like this factor impact on like growth of population, and how much this factor like impact on growth of population. So if you're moving forward like in the both direction, looking toward this like in specific direction that we are called, this particular vector is called eigenvector. So eigenvector have some specific direction, they never change its direction. Okay, they never change its direction by rotation, tilting, anything else, twisting it. They always adjust its value, and that value is called eigenvector. So now suppose this vector v1. Okay, so we can arrange this vector v1 by we can consider this eigenvalue as a lambda and eigenvector as a b. Okay, so this is eigenvalue and this is eigenvector. Instead of looking like there are lots of types of like there are entire vector space, we are discussing about eigenvalue and eigenvector, and the special property of the eigenvalue and eigenvector is like unchanged direction. They never change its direction. This I really emphasize this particular term, unchanged direction. Because of that, this particular term is very important, and that particular term create a difference between all of them. Okay, so all of the vector. So that's the important part to discuss. So eigenvector and eigenvalue are different in such way like eigengroup. So it is all about something like you can say educated group. So consider this educated group the vector 1, and this particular vector are adjusting its length by along, sometime it elongates, sometime it stretch, and sometime shrink, sometime it reverse. It is reverse is possible. Okay, reverse it means like it changing to negative and something also. Okay, so it's all about eigenvalue. This is the educated group, and in this both parameter, I want to know this which parameter like impact on what the particular growth of the population. So I think like eigenvalue and eigenvector, the main application like PCA and something like linear regression is the best application for this both of them. But I will discuss all this particular topic in next video. But today is all about like something eigenvalue and eigenvector. So understand this eigenvalue and eigenvector, like they have some unchanged direction. The vector where there is a no chance, you can say there is a no chance for changing a direction. Okay, so that's the eigenvector and eigenvalue. So that's all about it, like two parameter, and you can adjust this particular eigenvalue according to their changing side string. If this particular value is greater than 0, if they're less than 0, the vector will be reversed. As we know, like we discussed lots of topic about this particular vector scaling. Okay, that's all about it. So I think the three property of the eigenvalue and eigenvector, the most important part is like the first one is like sum of all eigenvalue is equal to trace. Trace refer to the diagonals of this all the particular thing. Like now suppose we have a matrix. Okay, A, B, like we have a square matrix C and D. The sum of trace refer to this A plus B, A plus D is equal to trace. A plus D is equal to trace. Okay, so that's the trace. Okay, and that trace is equal to the sum of all eigenvalues. The sum of all eigenvalues. Okay, like if the particular vector are shifting in different direction. Now suppose they are elongate, sometimes they shrink, and sometimes they stretch much more. And how can we know the particular value, each the sum of all value? Like if you need to find out that what is the ideal condition of the particular vector changes, what is scaling vector that we are using to find out like this particular trace method. Okay, okay. Second thing, like product of diagonal, that product of diagonal refer to something A into D and C into, okay, minus C into D. So that's the particular product of diagonal is equal to something you can say the product of all eigenvalues. So that if you go into product of all eigenvalues, then you got a equal product as the sum of diagonals of the volume, like product of diagonals of the both direction. Like so, okay, second thing done. And our last is all about eigenvalue never non-zero. Okay, so it is all about is equal to non-zero, and the eigenvalue never zero. They never come in the position of the zero. And okay, so that's all about it. So in short, if you want to explain this particular thing, eigenvalue and eigenvector is all about something a vector which are not going to change its direction. Okay, it stay at the same direction, but the scaling factor change, the scale quantity change, and the vector will adjust according to the model learns. Okay, that's all about it. Okay, so that's all about the particular thing. And I'm not going to just depth of the derivation of the formula and something like finding manually about eigenvector and eigenvalue. Because of that, this is not necessary to discuss, because we need to discuss what the idea behind this particular thing. So discussing the idea that really create impact. Because of that, when we are creating a model, the only idea will work. Because as you know, like calculating a word, like calculating a number, it's already done by the computer. But the necessary part is like to discussing idea, what the particular idea used to solve a different problem. So we are going to discuss only for theoretical part, an idea behind any concept, and how this particular idea is used in computer to solve this particular thing. So connect all this real world idea, mathematical idea, your real world idea, and or abstract idea to in such as computer application, like how actually computer uses all this particular logic to understand and something or this particular thing. So that's all about it. And let's come to the real world application, and I will try to explain you all this particular thing like I teach you for linear transformation, all this particular stuff, for much clarity. Let's come to the agenda number 3. Hey, let's come to the last agenda, and our last agenda is all about like something. Agenda number 3 is all about real world application. So in this agenda, we are talking about something like real world application, and one of the best example is like athlete. We'll take lots of athletes, like data of lots of athletes. Like now suppose athlete 1, athlete 2, lots of them. So let's come to discuss. Now suppose this is athlete 1, and I think like something height x1, and something weight y2, something height x3, and something weight y3. Okay, and something y4 and something uh, x4, x2, x3, sorry. Oh, okay, yeah. Okay, so the basically where we the eigenvalue and eigenvector work here. So now suppose when a model want to learn, they look the first data. This particular data have some height x1, and if x1 increases, then y1 also increases here. And second, they look second data, athlete 3 data. This is athlete 4. Athlete 3 data. The height increases and the weight also increases. Second data is also says that height increases, weight also increases. The eigenvalue is all about adjusting the all the particular vector. Now suppose this particular vector, this is athlete data. Okay, so this is athlete data, and this vector is adjusted in such way like increasing height or weight, not at looking toward their increasing height and weight. So the adjusting eigenvalue and eigenvector, the model try to learn. Okay, now suppose this particular vector adjust the eigenvalue, applying like eigenvalue, adjusting eigenvalue, the model try to learn the from the first data, the particular visualization trick to like try to apply this particular visualization trick, but tricky to understand. They adjust eigenvalue in this particular vector. Now suppose this is a vector. Okay, this is eigenvector. Okay, this is eigenvector. Okay, so in this eigenvector they adjust the magnitude and stretches compresses according to it, and the most of the time they model observe that height is weight is directly proportional to height. Weight is directly proportional to height. If the weight increases, then height will increases. In fact, if the particular weight will increases, then height will increase. Then if you want to give a particular value, now suppose they also calculate the how much the height increases when the weight increases. Okay, now if weight is 1 kg increases, then height, I think, like 4 or 5 centimeter will increase. They calculate the all particular thing. The idea behind is all about something taking one vector to just as like evolution back like evolution like eigenvalue, adjusting eigenvalue to adjusting eigenvector here. So this vector is eigenvector, and they adjusted according to all this particular athlete data. Athlete 1 data, they adjusted and come to the shrink. Okay, in this particular one, this is the athlete 1, and the athlete 4 they elongate by adjusting like eigenvalue. So this particular this is work, and this is the weight and height, and they learn the pattern from this particular data by adjusting eigenvalue and eigenvector, that weight is directly proportional to height, and they calculate how much the weight increases, then how much the height will increase. Okay, again, if you give the particular value of data, now suppose if you give up 50 kg, they predict how much the particular thing increases, like how much the height will increase. Okay, 155 centimeter. So the model learn pattern here by adjusting eigenvalue and eigenvector. The real world, the main aim for explaining this real world application is all about something how they actually model learn pattern by using this eigenvalue and eigenvector. So here the pattern is all about something taking a eigenvector which is have a specific direction, like height, weight, and all anything else, and according to adjusting the parameter, like you can say eigenvalue. Okay, and they understanding eigenvalue, and they find a pattern here in that case, like athlete case, they try to adjust eigenvalue, and they learn the pattern. The weight is directly proportional to height. So if anyone want to if anyone give me any weight, then I will answer the how much the particular thing is going to on particular height of this particular person. So that's all about this real world application, and this real world application is very necessary to discuss, because of that that's help us to it help us to like something to create a relationship between two different abstract idea and something like real world application. So I hope so you understand much clearly, and again, if this particular video is going to productive for you, and okay, thanks for watching. It's my pleasure.